It's a long-standing mystery how Mars lost the water that flowed across its surface billions of years ago. Scientists now think they have an answer. Much of it became trapped in the outer layer of Mars, its crust. They argue that a vast amount of Mars' ancient water is locked up in minerals below the surface of the red planet. The findings have been discussed at the 52nd Lunar and Planetary Science Conference and are published in Science Journal. The study used measurements gathered from Mars-orbiting spacecraft, rovers, and meteorites. Researchers then developed a computer simulation of how water was lost over time. More than 4 billion years ago, Mars was warmer and wetter, possibly with a thicker atmosphere. Water coursed through rivers, cutting channels in the rock, and pulled in impact craters. Mars could have held enough water to cover the entire surface in a layer measuring between 100 meters and 1 kilometer deep. But by around a billion years later, Mars had made a transition to the colder, desolate planet we recognize today. We have known for a long time that Mars was much wetter in its early history. But the exact fate of that water has been an ongoing problem, said Dr. Peter Grindrod from London's Natural History Museum, who was not involved with the latest study. We already know from studies of the atmosphere of Mars that some of that water was lost to space, and ice deposits on and just below the surface tell us that some water became frozen. Escape to space. Earth has a magnetic shield, or magnetosphere, that prevents the atmosphere from escaping. But Mars' magnetic shield is weak and could have allowed the elemental constituents of water to escape from the planet. But the rate at which hydrogen, one chemical constituent of water, escapes from that atmosphere today suggests this mechanism can't explain where all the water went. Evelyn Hanscheller and colleagues from the California Institute of Technology, Caltech, in Pasadena now think they have come up with the answer. The results of their computer modeling work show that between 30% and 99% of Mars' initial water was incorporated into minerals and buried in the planet's crust. Co-author Prof. Bethany Ehrman, also from Caltech, explained that, by studying data from Mars missions, it became clear that it was common, and not rare, to find evidence of water alteration. She continued, when the crust becomes altered, it takes water, like liquid water, and sequesters it in a hydrated mineral that has water in its structure, so that it is effectively trapped. The authors suggest that most of the water was lost between about 4.1 and 3.7 billion years ago, during a stretch of Martian history known as the Nochian period. Martian climate change. Dr. Grindrod added, what this new study tells us is that a lot of that water, possibly the majority, could have actually been locked into the rocks on Mars. This process of hydration is capable of storing large volumes of water, up to an amount equivalent to a global layer a kilometer deep. Although most of the liquid water had probably disappeared after about 1.5 billion years after Mars formed, we see evidence of hydrated minerals at the surface today, in areas like Jezero Crater, which is currently being explored by the Perseverance rover. The early climate of Mars remains one of the most important topics in planetary science, and this study will help our understanding of the processes responsible for water loss.